Hello YouTube friends, in this video I'm going to be showing you how to prove that the magnitude of Z1 over the magnitude of Z2 is equal to the magnitude of Z1 over Z2. Now, in order to prove this, the first thing you need to know is that Z1 is going to be equal to x plus iy. Now, in this complex equation, x over here is going to be a real number and y over here is going to be a real number. Now, because this is the case, the magnitude of Z1 is going to be equal to root x squared plus y squared. Now, similarly, we have Z2, and this is going to be equal to P plus IQ. This P here is a real number, and this Q here is a real number, and obviously, this equation is a complex equation. Now, since this is the case, then the magnitude of Z2 is going to be equal to root P squared plus Q squared. Now, since we have all this useful information here, we will now need to figure out, okay, what Z1 over Z2 is in order to get another complex equation in order to get our proof. Now, Z1 over Z2 is going to be equal to x plus iy over P plus IQ, okay, because we know this up here. And we are going to multiply this by 1 so that we can end up getting our other complex equation. Now, if we multiply it by 1, we're going to get x plus iy over P plus IQ times P minus IQ over P minus IQ. Okay? And what we must do from here is expand the brackets at the top of this fraction and also expand the brackets at the bottom of this fraction. So let's do this next. Just going to have some coffee because my throat's a bit dry. Anyway, let's expand this. And we are going to do it in alphabetical order, and we are also going to use the FOIL method. Okay? So over here, we're going to get px, and then this multiplies this, minus iqx, okay, plus ipy, and then we get minus I squared qy. Okay, this is at the top of this fraction. Just going to make a line here. And then at the bottom we get p squared minus iqp. Sorry, does p come before q? Yeah, it does. So let me go back here. So we get minus ipq like that, and then we get plus I PQ, and then we get minus I squared Q squared. Okay, so this is what our fraction looks like right now, and we are going to simplify this further so we can end up getting our other complex equation. So if we simplify this, we get px, and then we get minus I squared qy. I squared is equal to minus 1. So this turns into plus qy. Okay, and we also get, just going to round this, we also get I multiplied by py, okay, minus qx in brackets. Alright, now I'm going to put brackets over here as well, so that we form a complex equation of the form a plus ib, where a is a real number and b is a real number. We can see that a in this case is going to be this, and we can see that b is going to be this over here. So now we've got a complex equation at the top of this fraction, which is going to be very useful. Now let's sort out the bottom. So we get p squared at the bottom, okay? Now we get I minus IPQ plus IPQ, so they cancel each other out. And we get minus I squared Q squared. Now minus I squared is going to be equal to 1. So we get plus Q squared over here at the bottom of this fraction. P squared plus Q squared. Now since we've got this, we can simplify further and get an even better complex equation. I'm going to go down here. If we simplify it, we get px plus qy over p squared plus q squared, okay, plus I multiplied by py minus qx over p squared plus q squared, okay? And we've got this complex equation here. I'm going to put brackets over here, all right, to demonstrate that this is going to be like A in this complex equation, and this is going to be like B in the complex equation. Okay, and this right over here that we've got is going to be very useful when creating our proof. I'm just going to take a little break and I'll be back to end the rest of this proof. So bear with me one moment. Okay, so I'm now back for the second part of this video. I'm kind of enjoying this. Haven't made a YouTube video for so long. Like this. Have you tried this Vimto? Tastes amazing. Anyway, we've got Z1 over Z2, okay? So now we can find its magnitude, and we'll need to find it in order to get our proof. So we know that Z1 over Z2 is this chunky complex equation over here. All right. Now let's get its magnitude. So the magnitude of Z1 over Z2 is going to be equal to root, look how big that is, brackets, px plus qy over p squared plus q squared squared plus brackets py minus qx over p squared plus q squared squared. This is really chunky, so let's simplify it. So it's going to be equal to root brackets px plus qy squared over brackets p squared plus q squared squared plus py minus qx in brackets squared over p squared plus q squared in brackets squared. Now, because we've got this, we end up with root px plus qy in brackets squared plus py minus qx in brackets squared over p squared plus q squared. What's going on here? Squared. Alright, now from here it's going to be pretty simple to simplify. However, we need to know what this is expanded and also what this is expanded. Alright, so I'm going to make a section over here for us to solve these problems. Alright, because we need to simplify what we've got here in order to complete our proof. So, what is px plus qy in brackets squared? Let's do this. Px plus qy multiplied by px plus qy. This is going to be equal to p squared x squared plus, let me see, pq xy, alright, plus pq xy plus q squared y squared. And this is the same as p squared x squared plus 2p qxy plus q squared y squared. Okay, so we know what this is. Now let's figure out what this beast over here is. So py minus qx multiplied by py minus qx will give you p squared y squared minus 2p qxy, alright, because we get this as well, we get this minus pqxy over here as well, plus minus qx times minus qx, which gives us q squared plus x squared. Okay, so we know what this is and we know what this is, so we can simplify this massive beast over here even further and complete our proof. Let's do this. So this over here, this beast, is going to be equal to root That's p squared x squared plus 2pqxy plus q squared y squared. Just going to make sure you see that. Plus p squared y squared minus 2pqxy plus q squared x squared over p squared plus q squared squared. Okay? Now, what is this over here? This chunky thing over here? It be simplified. I think it can. We've got a 2pqxy here, and we've got a minus 2pqxy over here. So they cancel each other out. So what we end up with is root p squared x squared, okay, plus q squared x squared, alright, because we've got this and this, plus p squared y squared plus q squared y squared, alright, which is this, over, in brackets, p squared plus q squared squared. Alright, you can actually see where this is going. I can see where it's going. Now that we've got this, we get root, let me see, x squared multiplied by p squared plus q squared in brackets, alright, which is this, plus y squared multiplied by p squared plus q squared in brackets, and that is over p squared plus q squared squared. Alright? And this is the same as root x squared plus y squared in brackets multiplied by p squared plus q squared in brackets, alright, over p squared plus q squared squared. Alright, so we've got this. Let's see what happens if we simplify this further. I need a little break to get my head in order and to give you the final part of this video. So stay tuned and we are going to have our proof. Just taking a little break. Hello again, guys. I'm now back again for the final part of this proof. And I'd just like to say, if you like what you're seeing, if you like my proofs, please follow me on Instagram, support my work, support my page, subscribe on YouTube as well, and help me continue making these videos. Anyway, let's get back to the proof. So, we know the modulus of Z1 over Z2 is currently this over here, okay? We've got this over here. Now we need to simplify it in order to finalize our proof. If you can hear some noise in the background, that's just rain. It's raining quite heavily outside. Anyway, back to the proof once again. This over here is going to be equal to root x squared plus y squared in brackets times p squared plus q squared in brackets over p squared plus q squared times p squared plus q squared. Now this is because we've got p squared plus q squared squared over here, okay? It transforms into this. Now we've got a fraction underneath this root sign, and we've got similar things here. We've got p squared plus q squared over here, and we've got p squared plus q squared over here in brackets. So they cancel each other out, okay? And what we're left with is equals root x squared plus y squared over p squared plus q squared. And this can be transformed into it can be transformed into root x squared plus y squared over root p squared plus q squared. Okay, thanks to simple algebraic rules. Now, what is this? And what is this? Root x squared plus y squared, according to the rules we set out at the beginning of this video, is this. It's actually the modulus of Z1, okay? So at the top of this fraction, we have the modulus, or the magnitude, of Z1, and this is going to be over this over here. But what is this over here? According to the rules we set out at the start of the video, it's equal to this, okay? Which is the magnitude of Z2. And this goes at the bottom of this fraction over here, okay? The magnitude of Z2. So we know that the mag Z1 over Z2 is exactly the same as the magnitude of Z1 over the magnitude of Z2. Therefore, we have our proof, okay? That the magnitude of Z1 over Z2 is equal to the magnitude of Z1 over the magnitude of Z2. Hope you enjoyed this video. If you like what you see, if you like the other videos as well, subscribe to my YouTube channel and also follow me on Instagram if you can. Thank you very much. I'm off. Bye.